In July of this year, astronomers detected a strange green visitor speeding into our solar system at nearly 60 kilometers per second. At first, it was dismissed as just another interstellar wanderer, the third after Oumuamua and Borisov. But as the weeks passed and the object now known as 3I Atlas drew closer to the Sun, something began to happen that no one could explain. Instead of following the predictable path of a comet, it started to expand and glow with a brightness far beyond expectations, its coma growing to sizes rivaling stars and its light curve breaking every model designed to track it. Scientists now warn that as it reaches its closest approach to the Sun, it could become even brighter and stranger still, defying everything we know about interstellar objects. But what is powering this rapid transformation? Is it just ice and dust sublimating under solar heat? Or is 3I Atlas hiding something far more extraordinary within its core? The first anomaly came when 3I Atlas crossed within 2 astronomical units of the Sun, where its apparent brightness suddenly jumped. Light curves are normally reliable. As comets approach the Sun, they brighten in smooth, predictable increments. But Atlas didn't follow the script. Its glow surged far more than expected, creating a leap in magnitude that left astronomers scrambling. Amateur observers with modest telescopes saw it flare brighter than entire models allowed, while spectroscopic readings suggested the glow wasn't just from its coma, but from deep within its nucleus. That implied something inside the object was fueling its light, a process not seen in ordinary comets. Some suggested hidden reserves of exotic ices were releasing energy as they vaporized. Others whispered of entirely new mechanisms, processes closer to nuclear reactions than chemistry. Whatever the cause, the fact remained. Atlas was no longer behaving like a simple chunk of ice and rock. It was becoming a beacon. As Atlas grew brighter, another mystery emerged: the eerie green tint radiating from its coma. Normally, such colors are linked to specific molecules like diatomic carbon, C2, glowing when struck by sunlight. But the first spectrographic analyses of Atlas had shown no overabundance of these molecules. And yet, as it closed in on the Sun, the green intensified. Astronomers in Namibia captured stacked images showing a dense emerald glow, shimmering as though something deeper than chemistry was unfolding. Some suggested new elements were volatilizing from the nucleus, hidden compounds being revealed only under extreme heat. Others proposed something far stranger, that its plasma environment, a charged mix of dust and ionized gases, was behaving like a self-organized system, its electromagnetic currents shaping light in ways that mimic life itself. To the untrained eye, it was simply a glowing green star in motion. But to scientists, it was a signal that 3I Atlas may not just be reacting to the Sun, it may be evolving under its touch. One of the strangest features of 3I Atlas is its tail, or rather, the lack of one. Comets always form tails streaming away from the Sun as solar radiation blasts dust and gas outward. But Atlas doesn't fit that pattern. Observations show its coma expanding in the sunward direction, forming what astronomers call an anti-tail, pushing directly toward the very star that should be stripping it bare. In stacked images, the green plasma halo points forward instead of trailing behind, a phenomenon that defies conventional physics. Some compare it to a magnetic sail, catching the solar wind in a way that bends plasma flows back toward the Sun. Others suggest it could be evidence of artificial structuring, fields manipulating charged particles into precise geometries. To skeptics, it is simply another anomaly in a long list. But to those who look deeper, the anti-tail may be the strongest evidence yet that Atlas is not natural at all, but something crafted, maneuvering through forces we barely understand. As October approaches, the chance to observe Atlas grows dangerously short. On October 21st, it will pass into superior conjunction, aligning directly with the Sun and Earth, hidden in the solar glare at the exact moment its behavior may peak. For ground-based telescopes, this creates a blackout window, a blind spot that ensures its most critical days will unfold unseen. Only probes orbiting Mars will have a clear line of sight during its closest approach on October 3rd, when it sweeps past the red planet at terrifying speed. Reconnaissance orbiters and spectrometers are already preparing to capture what Earth cannot, hoping to constrain the true size of its nucleus and measure the strange elements glowing in its tail. But time is running out. By the end of October, Atlas will have passed perihelion, fading again into the deep as fast as it came, leaving only questions in its wake. And for now, we are left wondering whether we are witnessing just another interstellar rock, or a signal from something far older, far more intelligent, and far more deliberate. October 3rd is now marked as one of the most critical dates in the study of 3I Atlas. On that day, the object will make a close flyby of Mars, passing within a quarter of an astronomical unit of the red planet. For astronomers, this encounter is a golden opportunity, as multiple orbiters and rovers are already stationed around Mars with instruments capable of measuring brightness, spectrum, and even chemical signatures. NASA's MAVEN, ESA's Trace Gas Orbiter, and China's Tianwen-1 are all expected to turn their eyes toward Atlas, attempting to capture what Earth-based telescopes will soon be unable to see. If the nucleus truly harbors exotic elements or processes, Mars-based data may provide the first solid confirmation. Yet this proximity has sparked another unsettling thought. If 3I Atlas can influence electromagnetic fields, as some of its plasma behavior suggests, what effect might it have on the sensitive electronics orbiting Mars? Could this flyby be not just an observation opportunity, but also a test? As Atlas plunges deeper into the inner solar system, a frustrating irony emerges. Its most dramatic transformations are expected to occur precisely during the time when it will be impossible to observe from Earth. Between October 21st and 31st, Atlas will be hidden by the glare of the Sun during superior conjunction. That means no ground-based telescope can record its perihelion, the critical point of closest approach to the Sun where its activity will peak. To astronomers, this is both maddening and suspicious. For random comets, blackout windows are coincidences of geometry. But for an interstellar object already defying expectations, some now whisper whether this timing is more than chance. Could Atlas's trajectory have been designed to ensure its most vital moment unfolds unseen? If so, then what is it doing during those hidden days, shielded from our gaze by the very star it orbits? The closer Atlas moves toward the Sun, the stranger its composition appears to become. Initially, observations revealed a faint mix of nickel, carbon monoxide, and common cometary compounds. But as its coma expanded and brightened, new elements began to appear in its spectrum, most notably diatomic carbon creating the striking green glow. The problem? Atlas should not contain that much C2, at least not based on its early readings. That means its chemistry is evolving, changing in real time as it reacts to solar radiation. Some suggest we are witnessing buried layers being exposed, revealing exotic ices and molecules frozen for millions of years. Others, however, argue that the shifts look too structured, almost like stages in a process, an unfolding sequence rather than a random release. If this is true, then Atlas is not just reacting to the Sun. It is transforming, step by step, in a way that resembles not geology, but engineering. Atlas is only the third interstellar visitor humanity has ever recorded, after Oumuamua in 2017 and Borisov in 2019. Each has carried its own enigma, Oumuamua with its strange cigar shape and unexplained acceleration, Borisov with its hypercometary activity, and now Atlas with its runaway brightness and anti-tail. Taken together, a troubling pattern emerges. These are not random drifters. They are anomalies, each one stranger than the last, each one pushing the limits of what science can explain. If they are natural, then the universe is far more complex and chaotic than we ever imagined. But if they are not, if there is intent behind their visits, then perhaps these objects are not independent mysteries at all, but chapters of a larger story unfolding across centuries. And if that is the case, then 3I Atlas may not be the last. It may simply be the herald of what comes next. As September unfolded, astronomers noticed something alarming in the recorded light curve of 3I Atlas. Instead of following a smooth rise in brightness consistent with its approach to the Sun, the object suddenly leapt upward, increasing far faster than any prediction allowed. Brightness in astronomy is measured in magnitudes, where even a single jump means a dramatic increase in light output. But Atlas wasn't climbing step by step. It was skyrocketing, pushing models into irrelevance. The object that began as a faint dot requiring advanced telescopes to detect was now edging toward visibility with smaller instruments, suggesting it could even become bright enough to be seen without aid if the trend continues. But what alarmed scientists most wasn't the brightness itself. It was the curve, the exponential growth, a hallmark not of chaotic natural systems, but of controlled release. Something was accelerating Atlas's output with precision, and the closer it got to the sun, the faster that process seemed to unfold. Orbital charts revealed that Atlas's path was eerily precise. With an inclination of just 5 degrees off the ecliptic plane, the object seemed locked into the same orbital sheet as the planets, sweeping past Mars, then Jupiter in 2026, almost like a guided tour of the solar system's inner worlds. This low inclination puzzled dynamicists, because interstellar objects typically dive in at steep angles, cutting through planetary orbits rather than aligning with them. But Atlas looked tailored, like it had chosen a path to maximize encounters, slipping into a lane where its gravitational interactions would be strongest. Even stranger, its trajectory placed it in exact alignment during astronomical events, a superior conjunction with the Sun on October 21st during a new moon in the constellation Virgo. To some, this was nothing more than celestial coincidence. To others, it was too precise to ignore, raising the disturbing possibility that Atlas's path was not random, but written. As its coma expanded under solar radiation, researchers began describing Atlas not just as a comet, but as a plasma laboratory. Dust particles within the coma became charged, ions and electrons tangled into filaments, and structures resembling self-organizing systems began to appear. In laboratory experiments, dusty plasmas often behave in ways eerily reminiscent of biological processes, forming clusters, oscillating rhythms, and wave-like communication patterns. Now, Atlas seemed to be displaying these same traits on a cosmic scale. To some plasma physicists, it looked less like an inert ball of ice and more like a dynamic organism, feeding on solar wind, metabolizing energy into radiant light. Could Atlas be alive in a way we do not yet define? Conscious matter, sustained by plasma dynamics rather than carbon and water? Or is it simply a natural phenomenon so complex it mimics the behavior of life? Either answer would change everything we think we know about what interstellar objects can be. Perhaps the most haunting element of the Atlas mystery isn't its brightness, its trajectory, or even its plasma-like behavior. It is the silence surrounding it. Despite months of observation, major institutions like NASA and ESA have released almost no high-resolution imagery since August. Webb has the capability to resolve the nucleus, yet no raw data has been shared. The timing could be excused as caution or data verification, but combined with the blackout window in October, it has fueled suspicion. Why the secrecy? Why now, when public curiosity is at its peak? Independent astronomers have filled the gap, releasing stacked images and spectral analyses that reveal anomalies in real time. But institutions, with access to the most powerful tools ever built, remain quiet. For many, this silence is no longer just suspicious. It is confirmation that what is unfolding with 3I Atlas may not be something the public is ready to hear. Because sometimes, silence is not ignorance. It is knowledge too dangerous to admit. As 3I Atlas closes in on its October 3rd flyby of Mars, tension within the astronomical community has reached a breaking point. The planet will serve as the first real checkpoint in its path, and orbiters circling Mars are preparing to capture data Earth can no longer collect. Yet beneath the excitement is unease. Atlas's speed, approaching 68 kilometers per second, means any subtle gravitational tug from Mars could reveal much about its true mass, and possibly whether it hides more than ice and dust within. If the flyby produces unexplained accelerations, the implications would be staggering. Would it mean propulsion? Would it suggest intelligence? For now, instruments wait in silence, ready to measure every flicker of light and every shift in trajectory. But for the first time, humanity must ask itself, what if the planet next door becomes the stage for our first undeniable proof that Atlas is not what we think it is? Atlas's most bizarre feature remains its so-called anti-tail, a stream of plasma and dust pushing not away from the sun but toward it. This phenomenon violates centuries of cometary science, where radiation pressure always pushes material outward. To see an interstellar body do the opposite is like watching smoke flow into a fire instead of away from it. Some astrophysicists speculate that electromagnetic interactions are reshaping its coma into this sunward form, while others whisper that it looks suspiciously like control, as though fields around the object are being manipulated to harvest energy directly from solar winds. To skeptics, it is simply another anomaly to add to the list. But for those looking deeper, the anti-tale is not just strange, it is evidence of defiance, a sign that Atlas is bending the rules of physics in ways nature alone never could. When placed in context, Atlas does not stand alone. In 2017 came Oumuamua, the silent, elongated traveler that accelerated mysteriously out of the system. In 2019, Borisov followed, displaying comet-like traits but on an interstellar trajectory. And now, Atlas has arrived, brighter, stranger, and far more active than the others. 3 interstellar visitors in less than a decade is not coincidence. It is a pattern. Astronomers once assumed such encounters were rare, perhaps once every 100 years. Now, in less than 10, we have seen 3, each more enigmatic than the last. If this is a cycle, then it is accelerating, and the question shifts from why now to what comes next. Are these visitors scouts, each one escalating in complexity? Or are we simply catching up, our instruments finally sharp enough to see what has always been happening above our heads? Either way, the cycle has begun, and Atlas may be its most dramatic chapter yet. As the calendar races toward October 21st, when Atlas slips into superior conjunction, the sense of urgency grows. Observatories worldwide are already preparing for the silence, knowing that for nearly 10 days, Earth will be blind to Atlas's most critical moment, its perihelion on October 29th. The blackout ensures that if anything extraordinary happens near the Sun, humanity will not see it. To astronomers, this is the cruelest twist of all, to finally encounter an interstellar object so full of anomalies, only to lose sight of it at the exact moment it might reveal its secrets. And yet, there are whispers that probes and classified satellites will continue watching, their data hidden from the public. If so, then the countdown to conjunction is not just about astronomy, it is about access. Who will see Atlas's truth, and who will be left in the dark? While Atlas's glowing coma dominates most images, scientists are desperate to measure the true size and structure of its nucleus. Early estimates suggested something small, perhaps just a few kilometers across, but the energy pouring from it tells a different story. If its brightness really originates from within, then the nucleus could be far denser, holding exotic materials capable of sustaining outputs that no natural body of its size should. Some even suggest the nucleus is layered, hiding pockets of compounds that volatilize only when exposed to the extreme radiation of the sun. But the strangest possibility is that the nucleus itself is not a solid core at all, but hollow, an interstellar shell designed to protect whatever lies within. The lack of high-resolution Webb data in September has only intensified suspicion, because if the nucleus truly defies expectations, then its image may be the most unsettling photograph ever captured of an object in space. As Atlas brightened, radio astronomers began detecting subtle fluctuations in background noise, tiny modulations that appeared to sync with its movements. Officially, these were dismissed as instrumental interference, but the timing was too precise, matching periods of sudden jumps in brightness and plasma activity. Were these signals natural, the byproduct of charged particles interacting with solar winds? Or were they something more deliberate, like structured transmissions hidden within the noise? The idea is controversial, but history weighs heavily here. Oumuamua's anomalous acceleration once sparked similar questions about signals and technology. Now, with Atlas displaying its own rhythm, some argue we may be hearing whispers not from deep space, but from within our own neighborhood. And if that's the case, then the question shifts from, is it sending, to who is it sending to? The emerald glow intensifying around Atlas has become more than just a visual curiosity. It may be the key to understanding its transformation. The presence of C2 molecules explains the color in part, but the scale of the glow exceeds anything ordinary chemistry can produce. Spectral analyses show shifting chemical profiles, with compounds appearing and vanishing as though orchestrated in stages. To some researchers, it looks like layers peeling back, revealing hidden reservoirs buried within. But to others, it resembles a process closer to programming, where specific chemical states are unlocked at precise distances from the sun. If this is true, then Atlas is not just reacting randomly. It is following a sequence, an interstellar script that only unfolds when the right conditions are met. That script is now being written across the sky in green fire, and no one knows the final act. Every day, Atlas grows brighter. Every day, its anomalies multiply, and every day, the silence from institutions deepens. The public watches through scattered amateur images, blurred and stacked, while the most advanced telescopes in human history remain strangely quiet. Rumors swirl of embargoed data, hidden spectra, and internal debates about what should and should not be released. Behind closed doors, the narrative may already be shifting, from science to strategy, from curiosity to caution. Because if Atlas is not a comet, if its behavior cannot be explained by natural models, then humanity is not facing just a discovery. It is facing a presence. And the greatest fear is not what we know, but what we don't. Because every orbit, every alignment, and every surge in brightness points to a single truth. Atlas is approaching its moment, and we may not be ready for what happens when it arrives. From the moment it was first detected, 3I Atlas was never just another rock wandering into our solar system. It has grown brighter and larger with every passing week, its green glow intensifying, its plasma behaving as though alive, its trajectory unfolding with the precision of a script rather than the chaos of chance. At first, astronomers thought it was simply unusual, then they admitted it was unprecedented. Now, as it races toward perihelion, it has become undeniable. It is something else entirely. What terrifies scientists most is not what we have already seen, but what comes next. During its blackout window, when the sun hides it from our view, Atlas will undergo its closest approach, the moment when its secrets may finally be revealed. But we may not be watching. We may not be allowed to. Already silence has descended from the world's leading agencies. Already whispers of embargoed Webb data and unexplained radio modulations suggest that knowledge is being contained. And that silence speaks louder than words, because it means this isn't just an astronomical anomaly. It's a paradigm shift too great to unleash without control. If Atlas is natural, then it is rewriting every law of cometary physics we thought we understood. If it is not, then we are witnessing something deliberate, an object designed, a presence arriving on a schedule older than civilization itself. Either way, humanity is no longer a bystander to the cosmos. We are participants in a story that began long before us, a story written in trajectories, resonances, and cycles that we have only just begun to notice. And perhaps that is the most unsettling truth of all. Because if Atlas is following a sequence, then its expansion, its glow, and its silence are not the end of the story. They are the beginning. A beginning we cannot stop, cannot control, and perhaps were never meant to. And now, as the sun swallows it from our view, we are left to wonder. When it emerges again, brighter, closer, and transformed, what will it have become?